Hello everybody, this is Math 140, day 4. So we're starting the next module, module 2 now. And at the beginning, surprise, it's a topic which you may find familiar. It's kind of a leftover from module 1, still about radicals and laws of exponents. So the title is right here, Simplifying Products and Quotients of Higher Radicals with Different Indices. It sounds like a handful, but it's not as bad as it sounds, okay? So let's look at some example. It always would say simplify. And for example, the square root of x to the 5th times the cube root of x to the 7th. Simplify this. The first thing you should do, this is really I'm going to say that this is the best way. Convert these radicals to powers. With fractional exponents. Fractional exponents. So you do that for both of them. The first one is x to the 5th to the power 1/2. Second law of exponents says this is x to the 5 times 1/2, or 5 to the power 5 over, x to the power 5 over 2. Now the second one, cube root of x to the 7, is similarly x to the power 7/3. Cube root always means raising to the 1/3 power. Okay, and then we need to multiply those two guys together. My expression is x to the 5 over 2 times x to the 7 over 3. Now comes the first law of exponents. This is equal to x to the power 5 over 2 plus 7 over 3. So the exponents get added together. We still need to simplify that. So we have a sum of two fractions. 5 over 2 plus 7 over 3. We can spot the common denominator 6. And you want to do this on the fly, okay? This is arithmetic. So we need to expand the first fraction by a factor of 3. That's the first fraction, 5 over 3 divided by 5 times 3 divided by 2 times 3. Second fraction is 7 times 2 divided by 3 times 2. So I'm writing 7 times 2. That's 15 plus 14 divided by 6. Which is 29 over 6. And that is just our exponent for x. So x to the 29 over 6. And this depends on the question. You really need to read the question carefully. In what form do they want the question? Do they want this written as a radical? So we could write this as the 6th root of x to the power 29 if we want to. And we can also split off a multiple of 6 from the 29. So this is 4 times 6 plus 5 at 29. So if you want, you can write the 29 over 6 as 4 plus 5 over 6. And if you do that and write this as x to the 4 times the 6th root of x to the 5th, then that is simplified radical form. This last bit. That is, I guess, kind of a standard, and Alex often asks about this simplified radical form. So I guess that would be their default, but the x to the 29 over 6 isn't wrong. Can't really complain about that unless the question has specified before that they want to have this as a radical or in simplified radical form. Okay, let's do an example with a quotient. I've got one square root of x to the 5th times cube root of x divided by the square root of x cubed. It's the same recipe. We convert everything to powers with fractional exponents. So cube root x is x to the 1/3. I've done the square root of x to the 5th before, and square root of x cubed, that's x to the 3/2. So what do we have? My expression is equal to x to the 5/2 times x to the 1/3 divided by x to the 3/2. Now comes the rule for negative exponents, or dividing by powers. You can rewrite this as product when you give that denominator a negative exponent. So x to the 5/2, x to the 1/3, x to the minus 3/2. And the first law of exponents says we can just add these fractions. So 5/2 plus 1/3 plus negative 3/2, put it like this, has a common denominator of 6 again. And we expand the first fraction with a factor of 3, so that's going to be 30. The next fraction with a denominator 6 would be 2/6. And the last fraction with denominator 6 will be negative 9/6. So like this. So this is 32 minus 9 is 23/6. And my answer is x to the 23/6. And rewriting it in simplified radical form, split off 18, that's 6. So this is 3 plus 5/6. That's x cubed times the 6th root of x to the 5th. People want to see those radicals for various reasons. They make some computations look better on paper, but for actually working with them, simplifying them, you can't beat those powers with fractional exponents. So everything gets converted there, you work with them, and then back to the format that you started with, to those radicals. So we can do some more examples in class. on Thursday, but this is the idea. Thank you.